Good evening, everyone. Hope all of you are fine and staying home, taking maximum care of yourself and your family. And the lockdown, it's not that boring and not that frustrating as we all thought. Today I'm here to discuss a part of drug acting on CNS, that is the central nervous system. So the part which I'm going to discuss here is sedative and hypnotics. So it's a very common class of drugs which quite commonly used in our day-to-day lives. So if we can describe it, so sedatives are the drugs which exert quietening effect accompanied by relaxation and rest, but do not necessarily induce sleep, while hypnotics are the drugs which induce sleep. Okay, so it is clear from the description that sedative are the class of drugs which relax the CNS but not necessarily induce sleep. मतलब नींद आना compulsory नहीं है, but in hypnotics they induce sleep. And but in both the hypnotics and sedative property usually are found in the same drugs. So a large dose of a particular drugs can be used as a hypnotic, and while comparatively the smaller dose of the same drug can be used as sedative, depending upon the condition of the patient or the necessity of the patient. Okay, so but then there are some exceptions where a particular drug is used only as sedative or only as a hypnotics. So as for example, potassium bromide is a good sedative, and but it does not exhibit any hypnotic action, while some other drugs like thiopentone sodium cannot be used as sedatives. So why these are used? So generally these are used due to an unforeseen emotional crisis. Emotional crisis invariably create these types of clinical conditions where the sedatives and hypnotics are to be used. So generally insomnia matlab deprivation from sleep. Insomnia caused due to short-term situational stress is usually regarded as the most reachable ideal circumstance or condition which necessitates drug treatment, not only to facilitate but also to augment sleep. So if we can say that the basic or the main characteristics of sedative hypnotics, there are three major characteristics which an ideal sedative and hypnotic must fulfill. So the first one is that must exert decrease in degree of consciousness for the purpose of inducing sleep without any lingering effect. Second one is that it should not have any potential effect on lowering or arresting respiration. And the third one is essentially it should not have the effect of abuse or dependence or addiction or tolerance. Okay, so sedative hypnotics are again classified into two classes, barbiturates and non-barbiturates, or in some cases it can be broadly classified as barbiturates. And the non-barbiturates part of the drug are again can be said as benzodiazepines, and some of them are miscellaneous. So barbiturates are the oldest known drugs used for the treatment or to relax the person to relax the body to get some sleep. So they are again classified based on the duration of action. So there must be some other basis of classification, but here we have discussed only upon the basis of their duration of action. So the long duration, the intermediate duration, and the short duration. Here the long duration lasts for more than 6 hours, intermediate duration lasts for 3 to 6 hours, and the short duration of action lasts less than 3 hours. So the long duration of action examples include phenobarbital, the intermediate includes amobarbital, and the short duration example pentobarbital. Now, and the second class is benzodiazepines. So these are used for the treatment of insomnia and anxiety. They are the class of medication that work in the central nervous system and used for the variety of medical conditions. So they are also used in some other medical conditions also. like anticonvulsants, and also use the sedative hypnotics. Okay, so here so now again these are also classified based upon the duration of action. Benzodiazepines are classified based on duration of action. Here the long duration, intermediate, and short. Here the duration is not the same as that of barbiturates. Here the long duration in means it lasts for 1 to 3 days, where the intermediate for 10 to 20 hours, and short duration lasts for 3 to 8 hours. So the long duration action example includes diazepam, nitrazepam. The intermediate includes alprazolam, and the short duration includes oxazepam. The third class is the miscellaneous class. So this class and these are again classified under this class. This can be somewhat classified based on their chemical or nature or chemical origin. So the amides and imides like glutathamide, alcohols and their carbamide derivatives like mefrobarbital, mefrobamate, and aldehyde derivatives like paraldehyde. Okay, so next we are going to discuss the SAR of benzodiazepines. So here SAR it's very hard to discuss without showing the structure, and right now I could not find any better idea to show you the structure than to use pen and paper. So this is the only idea I came up with. So here benzodiazepines, the SAR, the general structure of benzodiazepine, if you can see it here in the camera. So this is the general structure from which all the other derivatives of benzodiazepines which are used as sedative hypnotics have been derived. So this is 1,4-benzodiazepine. So benzodiazepine 1,4. So in the position 1 and 4 there are 2 nitrogen, so it is diaza. So 1,4 benzodiazepine. So this is the general structure of benzodiazepine. So different groups here, and some other groups in the nitrogen atom, and some other groups in this phenyl ring can give rise to the different types of benzodiazepine which are used as sedative and hypnotics. Okay, so in the 7th position, this here the electron withdrawing groups are necessary for the actions, necessary for the sedative hypnotic activity, necessary to show the sedative hypnotic activity. Here in this position, the different types of group which are used are chlorine, bromine, iodine, or CF3NO2. So there are some of the groups which are used. All the groups that are used in the 7th position must be electron withdrawing groups. So now if we can go further, we can say that the presence of an electron withdrawing the different points. Okay, so the different points for the SAR I already discuss here. The first point is the presence of an electron attracting group or electron withdrawing group at position 7 is required for the activity. So an electron withdrawing group must be present in the 7th position. The position 6, 8 and 9. So here if you can see the positions, so if you say 1, 2, 3, 4, 5, 6, 7, 8, 9. So 6, 8 and 9. So in this position no substitution is allowed. So if you substitute at these 3 positions, so the sedative hypnotic activity will be diminished. Okay, so the third point is the phenyl group at position 5 promotes the activity, and if an ortho means substitution at this position, ortho or diortho substituted phenyl group increases the activity, while a para substituted phenyl group decreases the activity. Okay, the next point is at the carbonyl. The 2-carbonyl functional group is optimal for activity. So this must be present to show the sedative and hypnotic activity. Okay, as this carbonyl group is important, this nitrogen group is also important for the activity. So, and then the next point is, if you are going to substitute any compound in this nitrogen, so the substitution must be small. Larger groups or very big groups, substitution with a very big group in this position can diminish the activity, the sedative and hypnotic activity of the compound. Okay, so this was all about the structural activity relationship for benzodiazepines. Now we are going to the next part, that is the synthesis of some of the benzodiazepines. So here I have in the class notes, if you have seen, I have given the synthesis of clonazepam and diazepam. Okay, so here again, to show the synthesis, I am using the pen and paper. So clonazepam, it is synthesized by treating 2 amino 2. Okay, so let me show you the structure. So this is 2 amino, or you can say 1 amino 2 dash chloro. So it will be 1 amino 2 dash chloro benzophenone. Okay, so yeah, so 1 amino 2 dash chloro benzophenone treated with 1, 2 dibromo acetaldehyde, 1, 2 dibromo acetaldehyde. So these two upon treatment gives an intermediate. So here you can see this amine. So this one H group of this amine gets removed. So one HBr gets removed here, and this part get attached here. So this is the intermediate. So upon further treatment with ammonia NH3, this Br again gets removed. So there will be a removal of one HBr molecule and gives this intermediate, which upon treatment with which upon further dehydration, so one H2O, 2H molecule and 1 O, so one H2O gets removed to give a cyclic structure, which is norclonazepam, which upon treatment with HNO3 gives clonazepam. So this and this structure are almost same, only one NO2 groups get attached to this benzene ring. So this is the final structure of clonazepam. The second synthesis which we have discussed is diazepam. So again same, it's almost similar. The first starting compound is treatment of 2 amino. So here you can see it is 2 amino 5 chloro 2 amino 5 chloro benzophenone, 2 amino 5 chloro benzophenone upon treatment with glycine ethyl ester. Upon treatment with glycine ethyl ester in presence of pyridine gives an intermediate which is nordiazepam. So this so the presence of pyridine here for the treatment is for the cyclization of the ring. So when pyridine is present, there occurs the cyclization here of this, which will give nordiazepam, which upon further treatment with methyl sulfonate gives diazepam. Yes, here, which upon further treatment with methyl sulfonate gives diazepam. Okay, so this was all about barbiturates. I have not discussed so many syntheses here in the video because it is very difficult to show without presenting the chemical synthetic process in the blackboard. So hope I made myself clear enough to at least the portion I have discussed here, and the rest the barbiturates and the other parts hopefully we'll discuss in the next video. And so for now, this is all what I want to say, and hope you all are fit and fine, and you are staying home. And at last, happy Ramadan, or Ramadan Mubarak to all of you. Thank you.